Good afternoon, everybody. Thanks for joining us. Sorry, there seems to be a little bit of a delay. Appreciate you taking the time here on this Thursday afternoon, uh, 2 o'clock Eastern Standard Time. I am joined by my co-host with the mostest, Lori Pearson. Lori, welcome to the webinar series. It is our distinct pleasure today. We are joined by Siva Adechame. And Siva is one of our principal architects in our Tanzu division. And he has a pretty informative brief that builds on what Jad shared with us last week around platform intelligence and where we're building sort of our private cloud platform from, how we're integrating, security and data management, certainly artificial intelligence and the ability to interact with, models of all types, frontier models, etc. And so, exciting times, a lot going on. And I think Siva has not only content, but a demo. Is that right, Siva?
Not today, Rob, but I'm going to offer that as if anyone wants a demo, I would like to schedule that
Yeah.
because there's a lot to cover. So I thought I'll show the content, and if someone wants to see this whole thing in action, then we can definitely do a follow-up and do that.
So Siva lives around the Virginia area. I can certainly share his address, and we'll do that offline. But we definitely have some really good demos of how what he's going to talk about and share work in production, and we will be happy to to host folks and kind of go into more depth. So maybe Lori, anything before we
yes,
get
just
started?
a gentle reminder that if you have any questions, please put them in the Q&A. That button is at the bottom of your screen, and the panelists behind the scenes will be answering those. And as applicable, we will be discussing those answers if the time persists. So with that, I will turn it over to Siva and have him get started on his platform intelligence webinar. Thanks.
Thank you, Laurie, and thank you, Rob, and thanks everyone for joining us today for this interesting topic. So personally, I have been doing AI since 2011. We did some statistical model-based financial analytics as part of a Wall Stream gig that I did. And since then, I've pretty much done most of the machine learning, deep learning, like CNNs, RNNs, and stuff like that. Since I want to say like 2019, 2020 is when I got myself involved in the large language models, because this thing was new. Like 2017 is when the whole idea of global attention and transformers and all this came in. In 2022 is when this whole thing became mainstream, right? So from 22 to now, a lot has happened. And between VMware, VCF team, and Tanzu team, which is what I am part of, we are doing a lot in this space, and I'm really happy to share what we are doing and how we can help you. So really to start with, right, the topic is about how do you harness frontier model, right? There are many ways to do that, and these are the top 3 ways that people are using today. Most of our customers, right, depending on where we are in the maturity. Again, this is what Anthropic has said too, that most of Anthropic users are doing as well. The first one is pretty basic. This is 2022 ChatGPT, which is like you prompt something, you ask a question, and then the model gives you an answer. Obviously, it's just not prompting. You may give some additional data, like a RAG use case, additional enterprise data and stuff like that. But essentially, it's basic use case where you're asking model with some context, and the model answers you. And then the next evolution is really like chaining models, right? You do one thing with one model, hand off information or output from that to another model, and then you kind of like orchestrate that. This is where most of our customers were as of last year. In fact, a lot of the proof of concepts that we worked with customers are in this space, right? It's just not augmented LLM. RAG is done, pretty much everybody understands that. In fact, most of you might have one, but workflow is where people were getting into. But the year of 2020, late 25 and 2026 is all about agents. Agents is where you're going away from this deterministic workflow to more like autonomous workflow, right? Agents can decide and act on things. So even though you can do all this, this is where clearly the industry is heading, autonomous agents, and how do we do that? So when we talk about harnessing frontier models, I'm going to anchor it based on agents because that's where the industry is trending, right? So with that, I really want to understand where you guys are in this journey. So I'm going to ask a poll question here to kind of like get an idea of where we are so I can tailor my content in the next 45 minutes. Can we please bring up the poll question? All right, so there is a question. It simply says like, are you guys exploring? Are you doing basic RAG? Are we doing, it's like this, right? So if you could just click on that, just take like 10 seconds and just let me know where you are, and then we can go from there. All right, can we close the poll and get the answers, please? All right, excellent. Looks like a lot of you are exploring use cases. You're trying to understand the risk posture and all that, which is great. And the next set is really like a bunch of you are doing agents. I don't know if you can see my screen, but a bunch of you are doing agents. This is great. Let's talk about it. And that's where most of us will be doing going forward, right? So really what these frontier models, all the LLMs and everything you talk about are really is the brain, right? It is really not only from a metaphor standpoint, also Anthropic has noted that the newer models are even showing signs of emotional thing in there. Like for example, if a model is given a stressful challenge, they can see stress indications in the neuron connection. So literally, this is becoming a brain, right? But the key thing to note this is, like with any brain, with anything, it is essential. This is what does the work, but it is not enough, right? In fact, what some of the research from AI labs are showing is that you can have like really advanced model, but if you give it some kind of like bad context, you will get the outcome you get is worse than an older model with better context, right? So an older model with better context window outperforms a newer model with bad context. The key thing to note is that yes, it's brain, yes, it is intelligence, but there is a lot more we need to harness this intelligence, right? That's really going to be what we're talking about. And there are many ways you use these models, brain in my analogy, to make to get the intelligence to take actions, and these are agentic patterns like reason and act pattern, reflection pattern, which is like you reason, act, and then you reflect. The model reflects on the results and then figures out what to do, or maybe something like a planning agent that there's a model that plans out what needs to be done and then spins off other models, sub-models, sub-agents to really do those actions. These are the patterns, as you can see, starting from really straightforward to more complex, like generating critique by playing one model as like, I'm building this, I'm critiquing this, and how do we do that? So, and then there are typical applications. For example, if you are doing CRM workflows, you may want a peer-to-peer deployment. If you are building customer-facing apps, you may want a triage and hand-up type design pattern. So these are patterns of how you deploy your agents, or agentic loops is what these are, right? So yes, we said that models are the brain, right? We need models, but models alone is not enough. We need additional stuff to convert models to make them into agents. So what are those things? Let's start with models, obviously. Without models, there is nothing, none of this is there. So models are the brain, it's core capable, and you need some place to run these models, right? Because end of the day, there has to be a runtime. It's executable, so it has to run somewhere. So you need an infrastructure. And then between this and the output you get, there is a whole set of things. Like you need frameworks. Like remember, we saw all those patterns like React and reflection and all that. So how do we implement those? So you need some frameworks for that, like LangChain, Crew AI, and there are a bunch of frameworks that you can use. And then agents need to talk to agents because we are talking about multi-agent patterns and stuff like that. So there needs to be protocol to do that. How do we enable one agent to talk to another agent? This is where Google released this A2A protocol. So that's important. Another thing is agents need to talk to tools. Like for example, your agent needs to talk to your Workday or your SAP or your database. So agent to tool communication is standardized through something called MCP. Right? So there are different protocols you need for whether the model interacts with another model or it interacts with another tool. Some sets of protocols are needed. And obviously, model need tools, like it could be talking to a database, it could be a RAG framework, or it could be memory stuff for both the short context and or long-term persisting the state, like where we are and things like that. So there are additional tools needed to take the model and to convert it to agent. Another thing that often gets overlooked is, okay, it's great, but once you talk about interacting with tools and interacting with other agents, identity is an important thing to consider. Like, for example, if I want this model to talk to my SAP module and get something, then the SAP needs to know that whether this agent has approval to get some data, can do something with the tool and stuff. So identity is important. Guardrails are important. What can you do? What is allowed? What is not allowed, right? Lastly, you need some interface because yes, you can build this amazing model, amazing pipeline, but if you're not letting your workforce interact with this in whatever way they want, then all of this is moot point. So interfaces are important as well. This is mostly for agent to user communication. In fact, these 5 components are so important that in February of this year, OpenAI coined this term called harness. This is not the harness as in harness the frontier model. This is the harness as in the horse kind of terminology, right? This is that kind of harness. This is the noun harness. So what they are saying is these components, these capabilities components, whatever you call them, these scaffolding is important to turn LLM into agents. Without this, you just have a brain. We all know brain can make things, but you need a body to function. And that's really what the key takeaway from this slide is. Frontier models or even, old previous models like any models, right? LLMs, to some extent, even the previous CNN, RNN, anything, it's a brain. And the 5 components is the body because that's what helps convert this LLM into agent. And you need some ground for this to function, and that's the infrastructure, okay? So this is what I call platform. When you put all these together, when you have model, you have infrastructure, you have all these harness components like frameworks, protocols, tools, identity and guardrails, interfaces. So to have all these components, make sure they all can be used in some shape and form to get the outcome you want. If you want to call some name for this, the easiest name to call this is platform, right? Because this is all integrated components. So if you, as I'm sure you are following this, and most of you are using things like Cloud Code or Codex and things like that, those are some sort of managed agents provided by AI labs like OpenAI and Anthropic and all that. In fact, if you're okay giving your data and your logic to some AI lab outside, then yes, you have options available, right? You definitely have Cloud Code and other agents, and there's a lot of companies out there. They're happy to take your data, happy to take your stuff and run agents, managed agents, and then you can build pipelines and stuff like that. That's great. But if you are a federal agency, or if you are like, let's say, healthcare agency, finance services with highly regulated stuff, right? Like if you are an intel agency trying to run some classified workloads, you don't want to hand over your data, your information. In fact, you won't be allowed by regulation. There are NIST controls, AI specific stuff out there. There are executive orders out there, right from White House saying you can do this, you can't do this, right? So for some of us, particularly in federal space, handing out this to an OpenAI or Anthropic comes into play, right? This is really what VMware as a whole is focusing on. How do we help you when you have to run stuff, whether it is AI workload or BI workload or app workload, in your own perimeter, in your own data center, right? So we want to bring that cloud-like capabilities to your data center, and that includes AI capabilities. So really what we are seeing in the industry is that when we talk about regulated use cases, going to an AI lab and using the managed agents provided them may not be an option for you. So what are your options? Your options are really build your own stack, because do it yourself is always an option for any one of us, right? You can go say, okay, I'm going to use this for my framework. I'm going to use this for my tools. I'm going to use this vector database. I'm going to use this thing for identity and guardrails. You can definitely do that. But the problem with any do it yourself is it's great if you're building something on your laptop, but if you're going to put it into production and run mission critical workloads on it, there is going to be complexity, right? You're talking about sometimes terabytes, sometimes petabytes, really large scale workloads, large number of agents talking to each other. So this is complexity in there. In fact, coding is not even complex anymore. Any one of us here in this call, we can write code really easily using Codex or Cloud Code or any of these code assistants, right? The complexity is really not writing the code. It's really managing all the components we talked about. And it's not just day one. Yes, you can assemble, do it yourself stack on day one. It's okay. But how do you maintain? Like, okay, this component changed. Now there is a CVE for that. How do you patch it? And this component needs to scale. Like my vector database needs to scale, right? My interface needs to run on tactical edge. So how do you do these things when all these components are they individually they can change, individually they have different characteristics, different technology limitations, and all of that. So that becomes a problem, right? Component maintenance become a problem, and there will always be execution gap when you're bringing in different components. It's about ATOs. It's about what's the cost of those products. Maybe one is expensive, one is not. What is the security aspect? What are you compromising? So there are gaps with your risk posture, with your compliance thing. Lastly, creative misalignment. And this is big, right? You want your engineers to focus on building agents, spending time on your harness engineering, your context engineering, your prompt engineering, because that's what is going to get you most value. Not trying to manipulate with vector database, not trying to manipulate with how do you connect through this MCP thing, right? So if your engineers end up doing all this other turning the knobs and stuff, they are losing time on building the right thing with the agents. So that is definitely we don't want. And lastly, there is also a kind of an assumption among AI. Remember, this space is new. Like it is a lot of development that we are discussing here happened in maybe last 1 year. I want to say last 6 months, right? So when people think of LangChain, Crew AI, no, those are libraries. Those help you implement the agentic patterns. They're not platform, because like we said, platform need a lot more than that. Okay. So with that, right, so far what we have established is that frontier models are great, but they are the brain. We need more than brain to really make these models into agents. And that is really your scaffolding or harness components, which is like protocols, frameworks, tools, data, identity, and interfaces, right? For regulated workloads, you have only two options. Either you can find some sovereign platform, or you can come with building these things, even though there are libraries out there that helps you simplify it. There isn't really a comprehensive platform for all those components. And that's what I want to talk to you about, what VMware can help customers. Obviously, there are many ways to solve this. This is how we are helping our customers. Let's start with model, right? Because remember that I said like models is the whole brain of these things. So you need models to run somewhere. That is our private AI service. That's part of VCF, VMware Cloud Foundation. And we need infrastructure to run this, right? That's our VMware Cloud Foundation. So VMware Cloud Foundation gives you elastic compute, elastic memory, network, storage. Whether you want GPU to be virtualized, CPUs to be virtualized, no problem. We can take that for you. If you want micro segmentation in your network for zero trust, we can do that, right? So basically, we take care of all of the infrastructure stuff. You don't have to worry about how do I do this, how do I manage my network, how do I manage my memory, and so on and so forth. And then comes the framework part. When we talk about frameworks, that's where Tanzu platform, which is another component, like Rob said earlier, it's VCF and other enabling component, right? Tanzu platform has something called Agent Foundation. This is really heart of the press thing that we are releasing. Agent Foundation allows you to build these agents, have a runtime, build a secure. It has build packs for building secured agents, right? So it gives you the whole thing we talked about for that agent lifecycle, right? And you want to use this in your high code app, like you already have an enterprise app, say Java app or something, and you want to integrate it. Then you have Spring AI from us to do that, which also supports this. But you're like, hey, that's fine. I don't want to do a high code. I want a low code option, right? Great, no problem. We have Agent Builder in our private AI service. We have RAG option, like low code RAG in our private AI service. So whether you want low code option for building some of the components we talked about, whether it is simple augmented LLM with the RAG or building agents, we got you covered with private AI. Or if you want more high code, really complex enterprise thing, Tanzu platform can come in and help, right? As for protocols, we have MCP gateway that can help with the MCP protocol. We also can support publishing apps as services, interact with that. So there's a lot that Tanzu platform can do that too. And identity, again, this is where the power of Broadcom comes in, because VMware, yes, VMware and Tanzu is the core foundation of it. But when we need other services, like for example, we need really solid identity management and stuff, we have products like Semantic. We have layer 7 API for gateway management, right? If we want to enforce policy on who can access what, we have a really robust API gateway capability from layer 7, which is another BU within Broadcom. So we are able to bring in these capabilities, assemble in it, and make it as a platform. And then talking about data, which again, I think that is going to be the key thing, and you will see that in following slides, right? Like data is key. That's what fuels your model. Tanzu Data Intelligence is our offering there. I'll talk about that in detail, but that's really a data platform for bringing in data for AI on your private cloud, right? And you also need an orchestration tool. Really complex orchestrations may happen, right? You may want to process Kafka, or process some unstructured data, pull data from Twitter for OSINT and things like that. So that's where our atomic automation, which is again another robust tool out there that can help, right? Lastly, we talk about interfaces. This is there are only two ways you get interfaces. Either you're building with Claude Code, Codex, or manually typing the code, doesn't matter. Either you're building it or you're buying it, right? You get a COTS or GOTS application and get that. If you're building it, you can use Tanzu platform. Tanzu platform is a PaaS designed for building AI applications, particularly AI agents, with all kinds of interfaces and stuff like that you want. But if you're buying it, VCF has VKS or Kubernetes service. If you want to deploy it on VKS, or if you want to use virtual machines, you can do that as well. Basically, what we are offering here is that a full stack solution, all managed from Broadcom, and all solving individual capabilities that we talked about. But together, they give you this holistic capability of doing modern AI in a private cloud, right, for the classified use cases. And you may be wondering, oh, this looks like a bunch of products. Are you guys building it now? No, we have deployed these products in almost most of the federal agencies, right? Whether DoD organizations, Air Force, Navy, in civilian agencies like IRS, SSA, in IC agencies too. So these components are there, deployed, running in production, doing different workloads. All we are doing is we understand that modern AI needs these capabilities. So we're bringing them together, making sure that any missing pieces are built out. Like, for example, we built out private AI service because we understand that client needs low code, no code type builder, right? We built Agent Foundation on Tanzu platform because that's how software will be built going forward. So what we are doing here is we are taking the whole product offering we have, we are making sure that it fits what the customers need for building AI applications. So that's great. So let's say we have this AI platform, we have really solid models, and we are able to build that. Is that enough? Is that enough to harness your models? No. Why? Because models are great. They have this intelligence and all that, but it's really what goes in comes out, right? Garbage in, garbage out. If you give bad data to models, you are only going to get bad outcomes. Because models aren't really figuring out, it can to some extent figure out if there are any data issues, but to a large extent, data it just relies on. It says, okay, I have this data, I'm going to predict based on the algorithm I trained on, and this is how it is. So it is going to be very, very important that you give right data to right components, right? And you may be wondering, why is this important? Because the way app layer is transforming, basically your application is transforming, is some type of applications, for example, workflow applications, CRUD applications like create, read, update, delete type apps, right? These are probably going to kind of like go away, not go away. They're going to be really minimized because your agents can do a lot, right? So a lot of this will be disrupted. If you're having workflow applications, CRUD applications, those will be disrupted. Your system of records, like this is where your source systems like SAP, ServiceNow, Workday, all these things, those will be there. Those will continue to exist because those serve specific purpose. And AI will consume data from them. So those will be there, but they will probably be maintained using AI and all that. But the data from those is important. That's the message I want to leave with, right? And you will build some custom interfaces because your AI can do a lot of stuff. So you may build custom analyst workstation, custom command and control consoles, cockpit displays, and all of that. That will continue to be there. So there will be there, but the key thing is that your source systems will continue to be there. You will have data in them. How do you get this data from these source systems? How do you give it to AI? That's important because if you give bad data, you will get bad outcome. So how do we mitigate that? You need a solid data capability for doing that. What do I mean by solid data capability? How do we define that? So think about this, right? We have data in our source systems. We need to give that to AI. And AI needs data. And so for example, if I'm trying to understand an insider threat, right? I'm trying to understand what my employees are doing. In my source system, I will only have employees badging information, employees maybe HR information. I can bring in social media information. I can bring in how many copies they printed, how many copies how many they copied. So I can bring in all those information, but those are information. What AI might need is profiles. What's the sentiment score? What is the risk score? What is my access pattern and stuff? Because that's what it used to reason to figure out there is an insider threat or not. So to take from information to the kind of like the features that AI need, you need to take data through a certain architecture pattern. And the common industry pattern that everybody follows today is called medallion architecture, right? What medallion architecture says is you get all the data from the source, dump it as is into a bronze layer. And the reason for that is you want to know exactly what was in source, what was the snapshot at this point in time, and so on and so forth. Then you cleanse it, you validate it, you do deduplicate it, put that into a kind of like a confirm layer, and it's called silver layer. And then from silver layer, you take it, create the features, create any scores, run it through any ML or any pre-processing thing, and create the data set that your AI can use, your LLM can use. So that's the medallion architecture. You have bronze layer for source, you have gold layer for what AI consumes, and then you have silver layer where all this where you cleansed, transformed, deduplicated, and all of that, right? So if we are doing a medallion architecture, we need certain capabilities in the platform. Okay, those capabilities are really data sourcing. So remember AI, you are going to give AI probably some structured data. Let's say in case of insider threat, I am giving HR information, system access information, and I'm giving some unstructured data. I'm giving Twitter information. I'm even giving Instagram pictures, right? If someone is posing with really luxury goods, but it just doesn't compare with their pay scale, that may be a indicator of something. So I mean, my model wants to know that. So I may be inputting structured data, semi-structured data, unstructured data. I may be pulling them in real time, right? As somebody posts, I want to pull that, or someone badges, I want to pull that. Sometimes I want to load it in batches. So I should be able to bring in data real time or in batches or sometimes just during runtime. There may be sensitive data where I don't want to keep a copy of it. I just want to go access it, make my determination and drop it, right? So real time, runtime, batch. Your system should be able to process data, all of that. Your system should be able to load all this data because you may be talking about terabytes, petabytes, depending on the workload. So you should be able to do that. So that's important. You should have capabilities for that. And the next thing is, yes, okay, you are able to get data from source, structured, unstructured, semi-structured, real-time, batch, runtime, all of that. And you're putting that in a storage device, and you should be able to process this at scale because we are not, if you're only processing small volume, maybe you don't need it. But most of your use cases are going to be in hundreds of terabytes and sometimes in petabytes. So you need a platform that can process this at scale and really fast because you can't be chatting and waiting for answers to come forever, right? You want answers to be fast. So latency is important. And you may want to store data in different storage tiers because when you're talking about lots and lots of data, you want to make sure that if you put everything in NVMe, it's going to be fast, but it's not cost effective. If you put everything in S3, it's going to be cost effective, but not fast. So you got to get the balance and you want to say, this chunk of data is important or I need it for real quick processing. I want to put it in a fast tier storage. This chunk is for archival reasons. I want to put it in a cold tier storage. Your platform should be able to do that for you, right? So parallel processing is important. Like I said, when you're processing all this data and when you want your AI to make inference really quickly, you want to feed this data really quickly. So parallel processing is important. Okay, you got data from source, you have it in your storage layer, you're able to process it. But if you can't ensure quality of the data, then remember what I said, bad data in worst outcomes. So quality and governance of data is important. What do we mean by governance and quality? Number one, if your agent is going to pick a data, analyst can probably guess. Maybe they can look at something and say, oh, I see social security number in there, right? But agent, you need to tell it clearly what that information is about. So it can really use the right information for the right purpose. So business glossary is important. Each data should have, what does it mean? Where is it coming from? Like the lineage is important, right? If you want to prove out the auditability thing, you want to have lineage. You want some classifications, like for example, it could be security classification. It could be things like it's a PIA information, it is a PCI information, HIPAA, whatever, there could be, or like top secret, classified. So you need some classification information. You need to know who owns this data. If there is a problem, who is responsible for fixing it? And what's the data quality of it? Like, for example, if you're a marketing department, you're okay with some bad addresses in the customer database because you're like, even if I send out, hundreds of campaign, not everybody is going to respond. So some bad data is okay. But if you're finance department, every address is important. You don't want to send your invoice to wrong address, right? So depending on that, having an understanding of the quality score is important for the use case. Lastly, because this is the business interfacing thing for your data, this should be usable for your analysts, your scientists, your agents, anyone that wants this data. This is not just machine consumable, this should be human consumable as well. So what we have said so far is in the data platform, to implement this medallion architecture type pattern for your AI consumption, we need sourcing capability, we need storage capability, we need to have this quality and governance type, so quality and governance capability. We got all of that. Then comes the consumption part, right? Okay, before we give it to LLM, we need to do some pre-processing, like filter out, just get the right record, right? These are the relevant records that I want to give it to LLM. Or maybe convert that. Maybe images should be converted into vectors. Or maybe numeric should be converted into text, or whatever may be the case. You need to do some pre-processing. That could be machine learning, like you may run some random forest to figure out a score. You may do some k-means to figure out logical grouping and stuff like that. So there could be text analytics, geospatial analytics, graph analytics, who is linked to who, what is associated with what, and that kind of stuff. Time series to weed out the pattern, seasonality, and so on and so forth. So the idea here is you always have to pre-process something with your enterprise data before you give to LLM. Otherwise, the LLM will waste time and token figuring out things that it doesn't need to figure out. So pre-processing capability in your data platform is very, very important. In fact, a lot of this will be done when you go from silver layer to gold layer. So that this transition will happen as part of that pipeline. Having an in-database capability is essential, right? Lastly, when you're talking about AI and you're talking about inference, if you're able to expose the features in a caching layer, that makes the AI agents can access it really fast. That therefore your inference will be fast as well. So making sure that whether it is your vector embeddings or your all this data that we talked about, whether it all these things available in a caching layer is important. It's not just any caching layer. When you talk about federal use cases, there could be degraded, disrupted, intermittent, limited, low bandwidth type internet connection things, right? So your caching should be able to withstand that. There could be wide area distributed. Like for example, you could have command and control in North America, maybe some other and a tactical edge deployed in Europe. So you want to have a caching layer that can sync data between these two places in a wide area network distributed thing without any manual intervention, right? So it's definitely getting data in cache is important, but what is also important is these things, right? Here is an example of what that means. DDIL conditions. It is the denied, degraded, intermittent, low bandwidth condition. This is where edge use cases and other things come into play. If you have tactical edge, an internet connection is always not good. In this picture, I'm trying to show where I have command and control in Americas, and I have two forward deployed location, one in Europe and one in APJ. Three places, and I can make it all part of one cluster, right? Once I define that, any data you put in any one of this will get automatically synced up. If network goes down, no problem. When the network restores, the product will automatically prioritize it. No, there are logic on which one survives and so on and so forth. But it makes sure that depending on what you configured, the data will always be kept in sync, right? And the beauty of this is, let's say you have autonomous agents running in these areas, right? You have some autonomous agents running in your EMEA data center. You have some autonomous agents running in your APJ data center. Now, if you don't have this kind of cluster, all of those should be hitting your command and control in Americas. And typically, if you measure it in milliseconds, I actually did it. I deployed something in APJ and tried hitting my agent. My agent was in APJ and my cache was in Americas. And I measured about 172 milliseconds for that to go and get the data. But when I put it in Gemfire and when I kind of like ensured that Gemfire keeps it in sync, it cut down that into really like 1 or 2 milliseconds because it's really hitting the cache in the same data center. That is the power. You get like 100-fold, or I don't know. I mean, the power you get is really, really multifold because you are giving the data closer to the agents running in your data center. Okay, that's why this is important. This is often like not highlighted in the public forums and stuff because typically a commercial use case might use a public cloud. So this may be okay because public cloud has this capability. But when you're talking about sovereign, private cloud, classified use cases, mission critical use cases, that's not an option. So we need something like this to make sure that the data is accessible, available to the agents closest way possible. Okay. Of tactical edge, you can stream data. By the way, this solution comes with other things like RabbitMQ and stuff like that. So you have streaming engines, which you can stream from edge to command and control. And then you have data lake for storing all this raw data. You have Greenplum for processing the silver layer, gold layer. You have Gemfire for gold layer. So you have all these things. But the idea here is that VMware Tanzu has a product called Tanzu Data Intelligence. which can help you with all these things, with sourcing data, unstructured, semi-structured data from different places, real-time, runtime, batches, run them, process them at scale, apply quality and governance on top of it, and then do pre-processing with machine learning in database analytics, and then make it available to cache. That's what this picture is about. And this product runs on these capable. You can put this and you have no need to connect to public internet, right? It's cross domain. You can put it on low side, high side, and using our layer 7 gateway, you can get data from high side to low side to high side. That's how some of our IC customers use it. And there is zero trust, end to end, all the way from your network to data level. We have zero trust built into every layer. So, it's very, very secure. And we talked about building interfaces, right? We said, okay, you need to build agents, you need to build interfaces. If we are talking about high code, which is what most of the AI development is going, particularly with Cloud Code and Codex, most people are building agents, right? If you're doing that, then we have a PaaS offering called Tanzu Platform, which helps you to build apps, build data services, build AI services, all of that. And really, like, you get all these things. You get container lifecycle management, because you have to run this agent somewhere. You get zero trust networking. You get AI API key management, credential management, certificates, identity and access management. You get this whole thing we talked about for converting the LLM to agents, right? The whole stack we talked about. You get that from Tanzu Platform. So that means your engineers can focus on building stuff, coding stuff, not necessarily worrying about how do I manage my credentials? How do I, what happens if a CVE comes in? How do I patch that? How do I manage it, right? Platform can patch it for you. It can secure it for you. It basically, you give the code. This can build container, run it, scale it, manage it, patch it. It can pretty much automate day one and day two of everything you need for AI apps. Okay, how does this all come together? You may be wondering, wow, that's a lot, right? I mean, you probably, it's like, oh, this is too much, right? But let's make it real. Let's look at a use case on how all this come together. Let's say you are building you're assembling some kind of weapon system, and you have parts coming in from your suppliers and stuff like that. And you notice that the logistics systems notices some shipping delays of some components. And then the cyber system notices some cyber attacks. Your finance system notices a credit rate drop for one supplier. If analysts are looking at it individually, all these look like normal anomaly in the process. Like, for example, cyber attacks, yes, extremely common, right? Who is not getting attacked these days? Finance credit rate dropping, yes, things happen. Companies credit rates gets adjusted. So if you're looking at it, if analysts are looking at it individually, it seems like normal. But when you look at this in a fusion, if you look at all these things combined, you are going to build my system in the way I come. So I may have to have plan B and stuff like that. So that's the observe part. This is the OODA loop, probably all are familiar with, right? You're observing what is going on in your space, and then you're orienting yourself, like you're trying to figure out what does this mean, right? So observing is really sort of like data collection, understanding the data. Orienting is really figuring out what is going on. And then you decide. This decision is where, what do I do? Like when this kind of things happen, right? And then you act on it. Okay, finally, this is what I do, and this is what I act on it. So this is possible with human. In fact, most of this is today we do it with a human in the loop type thing. With agents, you can automate a lot of this. There could be an agent, a supervisor agent running that says, I want to look at this holistically. So there will be sub agents that goes and like, for example, a supervisor agent actually says, I want to analyze this across the board. Maybe there is a sub-agent. They can go and talk to different tools, like supply chain can talk to SAP. cyber can talk to network logs, complaints can talk to different places. So these agents can bring data and then reason on it and critique it. Remember the patterns we talked about? There are like triage and handoff, critique and peer-to-peer and all that. So this is where that kind of, you can use those patterns, figure out what works best, and then you can reason it, and then the supervisor agent can figure out, oh, I see a risk, right? But to do this, see all the things we needed. You obviously needed a platform, which is what we talked about. Like we said VCF. Then we said you need to build these apps, run somewhere, and that's where Tanzu platform comes. And then we said we need tools like Atomic for orchestrating all these things. We need a way to talk to these tools. That's the MCP protocol. And if you're moving sensitive data here and there, you want to make sure layer 7 does. So here is a list of how the platform I discussed earlier comes together to solve this OODA loop that I just talked about, right? And this is what I want to leave with saying. In the beginning, Rob asked, am I going to do a demo? I would love to show this to you all. If you are interested, please reach out to us. And we can definitely demonstrate this to you on how we are able to do this really complex fusion intelligence using different agents, like a multi-agent pattern across different tool set, running in an air-gapped environment, and how do we make this determination, right? We can absolutely demonstrate this to you. This is like totally, something that we can walk you through in depth. Okay, great. So we learned a lot. I know most of you probably understood knew of the pieces of it, and you probably have questions we do with this. Here is what I think. Typically, anyone in this journey, like we saw a lot of you are still figuring out what you need to do. Here is a good kind of like 3-step thing to think about. Number one is I really want you to think about what kind of AI use cases have to stay within your perimeter, right? The reason for that is if I cannot hand this over to Anthropic or OpenAI or any of these big AI labs, then you need to think about a platform, because we just proved that you need a platform to really take the frontier models and get agents, acting agents out of them, right? So you kind of need to figure out which ones I'm okay with using, AI labs. I'm not here to say that pick one over other. Just figure out what your strategy is. And there will be use cases. There will be things where you want to keep stuff in your premises. So figure what those things are. That will help you with making some determinations, right? And the second thing is, before you even go out and build a whole new AI agent app, make sure you have the right data. You have the right data strategy, because end of the day, if you don't have right data, it's sure you have this data strategy. Make sure you understand the different pieces. Why do you need a medallion architecture? It doesn't have to be exact medallion architecture, but some kind of industry standard architecture, because these industry standards exist for a reason, right? I've been doing data architecture since 1999, right? I built data warehouses on Teradata and Oracle Exadata, Greenplum, and all that. So we have been doing some or other form of this 3-layer thing since then. Medallion architecture is a relatively new term, but the concepts we have been using for a long time. And this thing is there for a reason. People build something, learn from it, and say, okay, this is a better way to do it, right? So it's kind of like learning from others. So figure out what data strategy you need, and make sure you have a plan. You don't have to solve everything, but make sure that is not overlooked. It's because often we get excited about, I want to do AI, great, but AI prototype is great, but production AI means you need good data. And the third suggestion I want to leave with is, we don't want to boil the ocean, whether it is AI or anything, right? We want to figure out what is my most critical use case, my low-hanging fruit, and then use this, because there will be ATO process. There will like I said, all these products are running in Fed agencies, in DoD, IC, and all that. But still, when you put together a stack, when you go through this process, you may figure out, okay, I need this approval, I need this thing. So it's kind of like figuring out, fleshing out the whole thing. And this is where we, with VMware and Tanzu, can help. We have something called MVP Starter Kit, because we understand that some of this is like you want to do it, but you probably don't have the right resources to do it. So if you get this MVP thing from us, then we can come in and do all of this for you. We can actually build out an app, going through this whole thing, setting the right tools, and from then you will be able to build on top of. Basically, we can set the template, we can give a protection working app, and then whole pattern, and then you can start build from there. So that's kind of like, again, recommendation wise, I would say figure out what your strategy is, figure out what you can hand over, what you have to keep, figure out what your data strategy before you go too far down the road, and then figure out what's the low hanging fruit. It's essential for you to know how this thing works. This is a fast moving field, right? What was, in November, people used to say review your prompt before the code, but now thought leaders are saying just review the code, don't review the prompt, right? So best practices and recommendations and all these are changing a lot. So it's important for you to do something, learn from it, and then improvise on it so that you can take it to the next mission critical thing. So really the recap here is frontier models are powerful. There's no denying about it. They are amazing. They almost have human intelligence type thing, right? But they are the brain. And we all know brain is not enough. Brain needs a body to function, right? And a body needs inputs. Data is that input. Platform and all these harness components like frameworks, protocols, identity. These are your body. So you need this whole thing. You need frontier models. You need trusted data. You need a platform to run all this together. And if you have all this, then you can get your decisive, trusted mission outcomes. And when you do it on a sovereign platform like VCF, you get a governed, auditable, like that thing you can deploy all the way in your command and control to tactical edge. So that's pretty much all I have from a content perspective. I'm sure you will have some questions because we covered a lot, and this is also really relatively new things here. So if you have any questions, or if you want to deep dive on any one of this, maybe data piece, maybe agentic AI piece, maybe a gateway piece, let us know. And lastly, demo requests. I would love to show this to you. We have my peers also in the call, and we would love to come in, meet with you, and walk you through this whole thing so you can see that how all this come together. So yeah, feel free to reach out to us. Laurie, are there any questions? Sorry, I'm not really tracking that.
No, not at this time. There are none that have not been answered.
So either I did a really good job or I really did a bad job. I don't know. I would love to have some questions.
We do have a few more
happy.
minutes. So if anyone has any questions, please don't hesitate to put them in the Q&A panel. And it has been mentioned, the session was recorded. You will get an email with that recording, and it will also be posted to our portal. Please feel free to share it with any of your coworkers or anyone within your network that may find some interest in it. As we all know, AI and harnessing models for the work that we do is super important and super relevant to today. I do know that everyone's time is valuable, and so I sincerely thank you for joining us today. I do want to remind you that we have another webinar starting on Thursday, April 30th, on centralized governance to automate your ATO. Then, are you ready? Starting in May, we will be talking about security, a very important topic for all of us, and talking about how VCF unlocks the full value with zero trust and AI. Starting on May 5th with our first cybersecurity session, it will be federal compliance and the new capabilities that are available within VCF to address not only current threats, but also compliance channels. challenges. So please look forward to that May series where the topic is cybersecurity and moving from reactive defenses to automated readiness. At this moment, questions out there. So again, I thank you for your time and look forward to seeing you again next Thursday.
Thank you. Thanks everyone for your time.